Hello everyone. Once again, welcome to PM Networking. Guys, topic for the day is GLBP. As you know, in day 1 of FHRP series, we had discussed HSRP. In day 1, we had discussed HSRP. In day 2, we had discussed VRRP. And today, in day 3, we will discuss GLBP. So if you haven't watched this video, HSRP video and VRRP video, first you need to watch that video, then only you can understand GLBP protocol. Okay, so request is first watch these two video, then watch this video, GLBP video. Okay, so topic is GLBP. Without wasting our time, let's begin. So see guys, GLBP stands for what? Gateway Load Balancing Protocol. Gateway Load Balancing Protocol. GLBP is also an protocol which is used to create virtual gateway for PC, for host, right? This is an protocol which is used to create virtual gateway for PC, for host. So see, GLBP stands for Gateway Load Balancing Protocol, and just like HSRP and VRRP, it is used to create a virtual gateway that you can use for host. But what is the difference between HSRP and GLBP? The GLBP is also an Cisco proprietary protocol. So first of all, you can run GLBP protocol only on Cisco devices. On non-Cisco devices, you cannot run GLBP. For non-Cisco devices, we have only one protocol, that is VRRP, right? By default, we cannot perform load balancing in VRRP, but by creating multiple group, we can perform load balancing in VRRP as well, right? But if devices is of Cisco, we can use GLBP protocol, so that this protocol will provide load balancing. So what is the key difference between GLBP and HSRP? One of the key difference of GLBP is that it can do load balancing, right? As you know, HSRP does not support load balancing for a single group. HSRP cannot provide load balancing for single subnet, for single group, or for single VLAN, but GLBP can provide load balancing for single VLAN, for single subnet, for single group. Okay, so with the help of GLBP, we can perform load balancing. How? We will discuss. In this video, we will discuss each and everything about GLBP protocol. We will discuss theory part as well and practical part as well. First, we will discuss theory, then I will show you practically. Okay, so see here, in this topology, this is my topology. Here you can see I have three default gateway. I have three physical default gateway. So now in this video, with the help of GLBP, we will create one logical default gateway by combining these three physical default gateway. Okay, so understand some point about GLBP first. Okay, so see here, all devices running GLBP elects a AVG. We have two terms in GLBP. First one is AVG and second one is AVF. AVG stands for Active Forwarder Gateway and AVF stands for Active Virtual Forwarder. AVG stands for Active Virtual Gateway and AVF stands for Active Virtual Forwarder. Okay, what is the use of AVG? AVG stands for Active Virtual Gateway and AVF stands for Active Virtual Forwarder. Okay, what is the use of AVG? Guys, what is the use of active router in HSRP? Use of active router in HSRP is to forward IP packet. Suppose if I will enable HSRP on these three router, out of these three router, one router will become active, one router will become standby, and one router will become listen. State of one router will be in listening Fine. So what is the use of active router? Active router is responsible to forward IP packet, right? Whenever this machine, this LAN user will access internet, all traffic will be go via active router only. But here in GLBP, AVG is not responsible to forward IP packet. ABG is not responsible to forward IP packet. See here, this is my topology, right? So when I will enable GLBP on router 1, when I will configure GLBP on router 1 and I will wait for 10 seconds, so router 1 will become what? Active. Router 1 will become AVG. So only one router in GLBP domain will become ABG. Only one router will become ABG, like active router in HSRP. In HSRP, for one group, only one router will become active. In the same way, in GLBP domain, only one router will become ABG. Suppose this router is ABG for group 1. But responsibility of ABG is not forward IP packet, right? So ABG is not responsible to forward packet of this user, right, to internet. So what is the use of ABG? ABG, responsibility of ABG is to provide MAC address. See, this is my virtual IP address, virtual gateway. So when I will configure this default gateway to this machine 10.100, and whenever this machine will access internet or it will send any traffic from any traffic to outside to their network, first of all this machine will generate ARP for their default gateway. Yes or no? This machine will generate ARP to resolve MAC address of default gateway, MAC address of 10.100. And ABG is responsible to provide MAC address, right? ABG, what is the use of ABG? ABG is responsible to provide MAC address of virtual default gateway. What will be the MAC address of virtual default gateway, right? And MAC address of default gateway will be the MAC address of AVF. MAC address of AVF, active virtual forwarder. Active virtual forwarder. And always keep in mind, for one AVG group, all router will be AVF. Include AVG also. AVG also will become AVF. Router 2 will also become AVF. Router 3 will also become AVF. So all router in GLBP domain will become what? AVF, and only one router will become AVG. So if you will enable, if you will configure GLBP on router 1 and you will wait for 10 seconds, but suppose within 10 seconds if you will enable GLBP on all router, definitely R3 will become what? AVG, because election criteria of AVG is similar like HSRP active router, right? First of all, router will check priority. Router who have highest priority, that router will become ABG. If priority is tie, then router will check highest IP address. So router who have highest IP address, that router will become ABG. But a router will wait only for 10 seconds for ABG election. So if I will enable GLBP on router 1 and I will wait for 10 seconds, so after 10 seconds, router 1 will become what? AVG for group 1. Suppose for group 1. And for this group, all other router will become what? AVF. So suppose this is my AVF1, this is my AVF2, and this is my AVF3. This is active virtual forwarder. This router 1 is forwarder 1, router 2 is forwarder 2, router 3 is forwarder 3. Right? Router 1 is ABG, active virtual gateway. So responsibility of ABG is to provide MAC address of AVF. Responsibility of ABG is to provide MAC address of AVF, and responsibility of AVF is to forward IP packet. AVF router will forward IP packet. So if this machine wants to communicate with 8.8.8, AVF will forward packet, right? And three router are AVF. Router 1 is also AVF. Router 2 is also AVF. Router 3 is also AVF. So all router will forward traffic to internet. So this machine will communicate via router 1 also, via router 2 also, via router 3 also. So we will understand how GLBP perform load balancing, how these things will happen. But here you need to keep in mind is that for one GLBP group, there will be one AVG, there will be only one AVG, and all other router including AVG will become AVF. Okay, so see here in this, in paint, all devices running GLBP elected as AVG, active virtual gateway. There will be only one AVG for a group, for a single group. For a single group, there can be only one AVG. एक ही AVG हो सकता है एक ग्रुप के लिए, fine. But all other devices take over this rule if the AVG fail. So any device can take any other router will become what? AVG if AVG will fail. Suppose this R1 is my AVG now, and if R1 will down, then definitely R3 will become what? AVG. So any router can take role of AVG if AVG goes down. अगर AVG डाउन हो जाता है तो कोई भी राउटर AVG का रोल ले लेगा. वो राउटर जिसके पास हाईएस्ट प्रायोरिटी होगी, राउटर हु विल हैव हाईएस्ट प्रायोरिटी और हाईएस्ट IP एड्रेस, दैट राउटर will become what? AVG. Okay. So till now we had discussed that for one GLBP group there can be only one AVG. Okay, and the role of AVG is to assign virtual MAC address to all other running GLBP, right? So role of AVG is to assign virtual MAC address. So this one is my AVG, this one is AVF1, this one is suppose AVF2, and this one is AVF3. So responsibility, second responsibility of this AVG, active virtual gateway, is to provide virtual MAC address to every AVF. It will provide virtual MAC address to AVF1 also, to forwarder 2 also, to forwarder 3 also. There are 3 forwarder 1 to forwarder 3. So these are responsible to forward IP packet. And who will provide virtual MAC address to this forwarder? AVG, active virtual gateway. Okay, now all devices will become an AVF, active forwarder, active virtual forwarder, including AVG. Whenever a computer send an ARP request, the AVG will response. Whenever computer will send ARP request, the AVG will response with one of the virtual MAC address of AVF. So suppose this is my forwarder 1, this is my forwarder 2, this is my forwarder 3, and R1 is AVG. So there are some PC1, PC2, PC3. So when PC1 will generate ARP, AVG will provide MAC address. So suppose AVG will provide MAC address of forwarder 1. So this machine will communicate with internet via router 1. But AVG will provide MAC address of forwarder 2. If AVG will provide MAC address of forwarder 2, then this PC will communicate to internet via router 2. Suppose when this machine will generate ARP for their default gateway, AVG will provide MAC address of forwarder 3, then this machine will communicate with internet via R3. Yes or no? Yes. So use of AVG is to provide MAC address to virtual MAC address to AVF, to forwarder, right? And guys, if you feel like it's complicated, then just wait for some time. When I will configure, when I will show you practically, you will came to know each and everything. It's very easy, right? It's very easy, just wait for some time. So what is the responsibility of ABG? ABG responsibility is to generate ARP response whenever host will generate ARP request for default gateway. And second responsibility of ABG is to assign one virtual MAC address to AVF, and all router in GLBP domain will become ABF, including AVG. Okay, so hope now AVG and AVF is clear to you. ABG is responsible to generate ARP response, and AVF is responsible to forward IP packet, right? AVF is responsible to forward IP packet. Okay guys, now see here, IP packet, and we have three types of load balancing algorithm in GLBP. We have three types of load balancing algorithm in GLBP. First one is round robin. In round robin, ABG will hand out the virtual MAC address of AVF1, then AVF2, then AVF3, and get back to AVF1 again, then AVF2, AVF3, again AVF1, AVF2, AVF3. So virtual MAC address is this one. This one is your virtual MAC address in GLBP, where X is GLBP group number and Y is ABF number. So suppose we have three daughter, R1, R2 and R3. Okay, R1 is AVG, right? If you will enable GLBP and you will not configure on any other router within 10 seconds, so router 1 will become ABG. So router 1 will become ABG, and router 1 will become forwarder 1 also, AVF 1 also. Then I will configure GLBP on router 2, so router 2 will become AVF 2. When I will configure GLBP on router 3 will become AVF 3. Now forwarder 1 is router 1, forwarder 2 is router 2, forwarder 3 is router 3. What will be the virtual MAC address of router 1? Virtual MAC address of router 1 will be 0007.B400.X. X is group number. So suppose my GLBP group number is 1, so MAC address will be 01, and then forwarder address, this is forwarder 1, so 01. What will be the virtual MAC address of forwarder 2? 01 is group number and 02. What will be the forwarder address of router 3, ABF3? Forwarder 3 is 01, is group number of GLBP. After that forwarder number is 3, so 03. This is virtual MAC address of forwarder 2, this is virtual MAC address of forwarder 3, this is virtual MAC address of forwarder 1. So if we are using round robin algorithm method to perform load balancing in GLBP, ABG router will provide MAC address to ABF1 first, then it will provide MAC address to ABF2, then it will provide MAC address of AVF3 to host. Again, when some PC will generate ARP, ABG will give MAC address of forwarder 1, then forwarder 2, then forwarder 3, again then forwarder 1, then forwarder 2, then forwarder 3. So in round robin algorithm method, load balancing will be happen on the basis of per packet, on the basis of per, you can say per host as well, because when this machine will generate ARP and ABG will provide suppose ABG is providing MAC address of forwarder 1, that is 0101. It will store that MAC address in their ARP table for 4 hours, right? So for 4 hours this machine will communicate with internet via router 1. Suppose again second machine will generate ARP, so it will provide MAC address of ABF 2. So this machine will communicate for 4 hours via router 2, right? In the same way, if there are one more machine, they will generate ARP. ABG will provide MAC address of ABF 3. Okay, so no problem. This is by default algorithm in GLBP. This is by default algorithm method. Okay, after that we have one more algorithm. We have two more algorithms. Second one is host dependent. We are not using much this algorithm to perform load balancing in GLBP, but see, if you want to send the traffic of one user, if you want to send traffic of one user via only forwarder 1 only, right, via forwarder 1 only, that your requirement is this machine can communicate with internet via forwarder 1 always, then you can use this algorithm. You can use this algorithm. A host will be able to use the same virtual MAC address for an ABF as long as it is reachable. So until your forwarder will be reachable, MAC address of default gateway for this user, for a particular user, will be same. Okay, and third one is weighted. So suppose we have 3 default gateway. I want to send 4 packet via this default gateway, 2 packet via this default gateway, and 1 packet via this default gateway. So I want to perform load balancing in 4:2:1. In this ratio I want to perform load balancing. I want to share more traffic via this link. I want to send 4 packet via this link, 2 packet via this link, and 1 packet via this link, right? So if requirement is like this, then you can configure this algorithm. Okay, now guys, let me discuss practically. This is theory. I know you have so much confusion. Let me clear your confusion with practical. See here in GNS3. See here in GNS3, let me turn on the device. First of all, here I have already configured IP address, right? On router 1 I am running 10.1, IP address is 192.168.10.1. On router 2 IP address is 10.2, on router 3 IP address is 10.3. Here I will configure suppose 10.10, here I will configure 10.20, here 10.30. Anything between router 1 and ISP I am running this network 1.1.1, right? This one, okay. And I have already configured IP address. Let me show you very quickly. Okay, so see on ISP. So IP interface brief, exclude unassign. Okay, so this is IP configuration of ISP router. Now here in this domain I will configure EIGRP for reachability. I will configure EIGRP for reachability. You can configure any routing protocol, but in real time you will configure NAT or PAT, right? You will define one default route toward ISP, then you will configure PAT so that these user can access internet, yes or no. But here I am going to configure any dynamic routing protocol. Okay, and I will make this interface as passive interface, this interface, this interface, and this interface, so that EIGRP neighborship will not form via switch, right? Otherwise EIGRP neighborship will form via switch also. Okay, so let me configure EIGRP on ISP router. In real time you are not allowed to configure ISP router, right? So that's why you will configure PAT on your edge router. So router EIGRP 100 network 0.0.0. Let me close it. Go to router number 1, config T, router EIGRP 100 and network is 0.0.0. Exit no. Router EIGRP 100 and passive interface fast Ethernet 0/0. See, this is my F0/0 interface. Okay, now can I ping 8.8.8, ping 8.8.8 and source fast Ethernet 0/0. So yes, I am able to ping. Okay, let me configure EIGRP on router 2 also. Config T router EIGRP 100 and network 0.0.0, passive interface F0/0. Let me configure EIGRP on router 3. Config T router EIGRP 100 and network 0.0.0, passive interface F0/0. Okay, now I am going to configure HSRP. First I will configure, sorry, not HSRP, GLBP. So first I will configure GLBP on router 1 and then I will wait for 10 seconds so that router 1 will become ABG. So that router 1 will become ABG. But until I will not configure GLBP on router 2 and router 3, this router will become AVG and there will be one forwarder, one AVF. There will be one AVG for group 1 and there will be only one AVF, that will be router 1. But once I will configure GLBP on router 2, there will be two forwarder, ABF 2. When I will configure GLBP on router 3, there will be three forwarder. Okay, so go to router number 1 first. This is my router number 1 and let me configure GLBP. The command to configure GLBP is same like HSRP. Interface F0/0. Here you need to type GLBP, after that group number and IP. Virtual IP is 192.168.10.100. Okay, just wait for 10 seconds. This router will become ABG. So GLBP. So now state is listening. Now there is, you can see here there are no forwarder, right? There is no forwarder because there is no ABG till now. But once ABG will elected, forwarder will be there. So see, now state is active. So GLBP. Now guys, see, this is information of ABG. This is information of ABG and this is information of AVF. This is information of AVF. So state of ABG is active. State of ABG is active. Virtual IP address is 192.168.10.100. Hello time in GLBP is 3 seconds. Hold on time is 10 seconds. Right? Redirect time. Okay, leave these things for some time. After that, preemption is disabled and active is local router. Standby is unknown. Priority is 100 and wait is 100 default. So we will change wait as well to perform which type of load balancing? Wait load balancing. Okay, and load balancing algorithm, by default load balancing algorithm is round robin. Group number, there is only one group. And guys, see, this is information of ABF. So there is one forwarder and this router is active for one forwarder. That means for forwarder 1, this router is active and this is MAC address. So see here, MAC address, these things are same and this is 01. This one is GLBP group number and this one is forwarder number. So forwarder number is what? 1. So MAC address is this one, 01. Fine. And this is owner ID. This is owner MAC address. This is physical MAC address of this forwarder, this interface, and this virtual MAC address to this of this forwarder is provided by AVG. by ABG. Who is ABG? This one. State of ABG is active. Now there is only one forwarder, right? There is only one forwarder, and for one forwarder this router is active. So for forwarder 1 this router is active, right? Now let me enable GLBP on router 2. So go to router number 2 and interface F0/0 GLBP group number 1 IP 192.168.10.100. Wait for 10 seconds. Wait for 10 seconds. And now you can see the log message, right? Log message for forwarder 2, for group 1 forwarder 2 state is active. So there are not two forwarder. So GLBP. So see, state of this router is active. This is state for state of this router is standby. This is state for ABG, for GLBP. Okay, and these are information of ABG, right? Who is active? Active is 192.168.10.1. Priority is 100 by default, right? Weight is 100. Okay, and now here you can see there are two forwarder. There are two forwarder. For one forwarder this router is active. This router is active for one forwarder. For one forwarder this router is active. For which forwarder this router is active? For forwarder 1 this state of this router is listen. For forwarder 2 state of this router is active, right? So for forwarder 2 state of this router is active, and virtual MAC address of forwarder 2 is 0102. 01 is group number and 02 is forwarder number. So this is MAC address of forwarder 2. So for forwarder 2 router 2 is active. For forwarder 1 router 1 is active, right? And by default preemption is enabled, but for ABG by default preemption is disabled. For ABG preemption is disabled, and for forwarder preemption is enabled, right? For forwarder preemption is enabled. Now let me configure GLBP on router 3. Interface F0/0 GLBP, after that group number and IP 192.168.10.100. Wait guys. So GLBP. So now see how many forwarder are there. There are only two forwarder. Just wait for some time. Now state of this router is speaking. Just wait. State is now state is standby, and for forwarder 3 this router is active. Now how many forwarder are there? There are 3 forwarder. Now you can see there are 3 forwarder, and for one forwarder this router is active. For which forwarder? For forwarder 3. For forwarder 1 who is active? 10.1. For forwarder 2 who is active? 10.2. For forwarder 3 who is active? Local router, right? Active is local and weight is 100, and this is virtual MAC address, right, which is provided by ABG, and AB is, who is ABG? Router 1. This is standby, and here is information of, this is virtual IP address, and active router is Where is information of active router? This one. Active router is 192.168.10.1. Okay, so ABG is 192.168.10.1, right? For forwarder 1, 10.1 is active. For forwarder 2, 10.2 is active. For forwarder 3, 10.3 is active. Now see how this router GLBP will perform load balancing. Guys, go to PC number 1 and let me assign IP address 192.168.10.10 suppose /25, and default gateway is 192.168.10.100. Okay, so MAC, so ARP, sorry, so ARP table is empty now. Let me ping 8.8.8.8. Yes, I am able to access internet. Yes or no? Yes, and now you can check ARP table. So ARP MAC address is MAC address of forwarder 1. This is MAC address of forwarder 1. MAC address of forwarder 1 is what? 0101 0101. MAC address of forwarder 2 is what? MAC address of forwarder 2 is 0102, and MAC address of forwarder 3 is what? 0103. Okay, so now see here, this is MAC address of forwarder 1. So PC1 is able to access internet via router 1. Let me clear ARP table, clear ARP, and let me ping again 8.8.8.8. Now ABG will provide MAC address of forwarder 2. Now ABG will provide MAC address of forwarder 2. You can verify. So ARP. See, this is MAC address of forwarder 2. This is MAC address of forwarder 2. Let me clear ARP again. Clear ARP, and let me ping 8.8.8.8 again. This time ABG will provide MAC address of forwarder 3. So ARP. See, this is MAC address of forwarder 3. So by default ABG is providing MAC address of forwarder 1 to PC1 at first. When ABG will receive first ARP packet, it will provide MAC address of forwarder 1. When ABG will receive second ARP packet, it will provide MAC address of forwarder 2. When ABG router will receive third ARP packet, it will provide MAC address of forwarder 3. And always keep in mind that maximum forwarder can be there in one group is 4. Max to max 4 forwarder can be there in one GLBP group, right? So there are 3 forwarder. We can add one more default gateway here, right? But you can't define 5 forwarder in one group. Okay, so this is load balancing in GLBP. This is by default load balancing behavior. Fine. Again, second thing that you need to keep in mind is when this machine will generate ARP request, ABG will perform, ABG will response, and it will provide MAC address of forwarder 1, that is 0101, right? And PC1 will make entry in their ARP table that MAC address of default gateway is this one, and that entry will be there for 4 hours, right? 4 hour ARP. After 4 hour, automatically entry will be erased from ARP table, right? We have discussed this thing in packet flow. Okay, so router will maintain their ARP table for 4 hours. Okay, now if this machine will generate ARP request, so ARP request will be received by ABG, that means router 1, and ABG will provide MAC address of forwarder 2 and MAC address of forwarder 2 is what? 0102. So it will also install this entry in their ARP table, and that entry will be there for 4 hours, right? In the same way, when this machine will generate ARP, ABG will generate response, and ABG will provide which MAC address? 0103 MAC address of forwarder 3. So there are 3 forwarder, right? Again, when R1, when PC1 will generate ARP, it will provide MAC address of forwarder 1, then again forwarder 2, then forwarder 3, then again forwarder 1 2 3 1 2 3 1 2 3. Like this, GLBP will perform load balancing. Okay, but here in this scenario, you can see this is my primary link. Here bandwidth is 8 Mbps, here bandwidth is 4 Mbps, here bandwidth is 2 Mbps. So I want to send 4 packet on this link, 2 packet on this link, and 1 packet on this link. I want to perform load balancing in this ratio, 4:2:1. What I can do? I can change the value of weight. I will set weight 40 here, I will set weight 20 here, I will set weight 10 here, right? So with the help of weight value, we can perform load balancing as well, right? And you have to change load balancing algorithm. You have to configure weighting algorithm to perform load balancing. Let me do that. First of all, see on PC1 ping 8.8.8.8. I am able to ping 8.8.8 via which router? Sorry, so ARP via router 1, right? But if I will clear ARP table, then it will generate ARP again, then router will provide MAC address of forwarder 2. So there are 3 forwarder now. You can verify on router 1 as well. Command is same, so GLBP, there are 3 forwarder. There are 3 forwarder. For 1 forwarder, this router is active. Okay, for forwarder 1, this router is active. For forwarder 2, which router is active? 192.168.10.2. and for forwarder 3, which router is active? 10.3. and virtual MAC address is this one. Sorry, this one. Virtual MAC address of forwarder 2 is this one, and virtual MAC address of forwarder 1 is this one. Okay, you can see here default, and here learn by ABG. Okay, now let me change the load balancing algorithm. First of all, how to change load balancing algorithm? On router 1 only you need to define load balancing algorithm. Sorry, not standby. GLBP group number 1 and load balancing. And if you will put question mark here, you can see you have 3 options: host independent, round robin, this is by default, and weighted. So I am going to configure weighted here. We are not using much host dependent, right? So you can configure host dependent as well. If you want to forward, if you want to give the MAC address of forwarder 1 to PC1, for PC1 to PC1, see, if you want to give MAC address of forwarder 1 to PC1 until ABG will forwarder 1 is reachable, until forwarder 1 is reachable. So you can configure this algorithm, host dependent algorithm. Okay, now my algorithm is weighted, and let me change priority here also. So GLBP 1 and weight, sorry, not priority, weight is 40. Now you can verify it. So GLBP, so GLBP, here you can see weight is 40. This is configured. right? Default weight is 100, right? Default weight is 100. So for forwarder 1, weight is 40. For forwarder 2, weight is again 100, weight is 100. For forwarder 3 also weight is 100. So let me change weight on forwarder 2 also, of forwarder 2 also. So go to interface F0/0 GLBP 1 and weighting is suppose 20. Go to router number 1, sorry 3, and let me change weight here also. Interface F0/0 GLBP group number 1 and weight is 10. Okay, now let me minimize it. Okay, now go to PC1. See, this is my PC1. Clear ARP, right? So ARP, there is no entry. Let me ping 8.8.8.8. Yes, I am able to ping, and let me show you ARP table. So ARP, so this is MAC address of forwarder 1, right? Let me clear ARP table, clear ARP, and let me ping again. And see ARP table now. This is MAC address of forwarder 2. So one packet is forwarded by forwarder 1, one packet is forwarded by forwarder 2, and let me clear ARP and let me ping again. And so ARP. This is MAC address of forwarder 3, right? Let me clear ARP, and now let me ping 8.8.8 again. And so ARP. This is MAC address of forwarder 1. Let me clear ARP. Let me ping again. Let me show you ARP. See, again MAC address of forwarder 1. So okay, let me clear ARP again. Clear ARP, and let me ping 8.8.8. So till now 2 packet is forwarded by router 1 and 1 packet is forwarded by router 2. So ARP, and this is MAC address of forwarder 2. Now 2 packet is forwarded by router 2. Now clear ARP, and let me ping again. Now router ABG will not provide MAC address of router 3. So ARP. See, MAC address of router 1. So till now 3 packet is forwarded by forwarder 1, and clear ARP and ping 8.8.8. Till now 3 packet is forwarded by router 1, and so ARP. 4 packet is forwarded by router 1, 1 packet is forwarded by router 2, and 1 packet is forwarded by 2 packet is forwarded by router 2 and 1 packet is forwarded by router 3, by forwarder 3. Let me clear ARP again. Clear ARP and ping 8.8.8. Now it will send 1 packet via router 2 via forwarder 2. So ARP, MAC address of forwarder 2, clear ARP, ping 8.8.8. So ARP, MAC address of forwarder 3. Now 2 packet is forwarded by forwarder 3. Let me clear ARP and ping 8.8.8. So ARP, this is MAC address of forwarder 1. Again 2 packet will be forwarded by forwarder 1. Sorry, what happened? What happened, guys? Just wait. Okay, so ARP, right? Again clear ARP and ping 8.8.8. Again it will provide MAC address of forwarder 1. See, and now it will provide MAC address of forwarder 2. Clear ARP and ping 8.8.8. So ARP, see, this is MAC address of forwarder 2. Clear ARP and ping 8.8.8. So ARP, MAC address of forwarder 1. So what is happening when this machine generate first ARP, right? Router 1 provide MAC address of forwarder 1, so traffic will be go via this router. At second time it will provide MAC address of this router, so traffic will go via this router. Third time it will provide MAC address of this router, right? Fourth time this router will provide MAC address of this router. Fifth time this router will provide MAC address of this router. Then it will provide MAC address of router 2. Then again it will provide MAC address of router 2. Then again MAC address of router 2. Then it will provide MAC address of router 1, then router 2, and then router 3. So here, sorry, it's performing load balancing like this. Let me erase it. First of all, it will provide MAC address of forwarder 1, then it will provide MAC address of forwarder 2, then it will provide MAC address of forwarder 3. Then it will provide MAC address of forwarder 1 for 2 times, then forwarder MAC address of router 2. Then again they will provide MAC address of forwarder 1 2 times, then again to forwarder 3, then 1 packet to forwarder 3, then again 2 packet to forwarder 1, then 1 packet to forwarder 2, 2 packet to forwarder 2, then again 2 packet to forwarder 1, then 1 packet to forwarder 2, and 1 packet to forwarder 3, like this, right? So 40% traffic will be go via router 1, right? 20% traffic will be go via router 2, and 10% traffic will be go via router 3. Okay, so this is load balancing in GLBP. So next thing is preemption. You can enable preemption here. So command to configure preemption, tracking, authentication, timer, these are same, so I am not going to configure that thing. This is all about GLBP, guys. This is all about GLBP. There is nothing like, if you want to enable preemption, command will be GLBP group number 1 and preempt, right? This is command to enable preemption. In the same way you can track link as well, you can configure authentication, you can change timer. Okay, so this is all about GLBP protocol, right? So go to router number 1, and if you will clear ARP, you can verify ping 8.8.8.8 like this. So ARP, MAC address of PC1, clear ARP, ping 8.8.8.8, MAC address of forwarder 2, clear ARP, ping 8.8.8.8, so ARP, MAC address of forwarder 3. So till now one packet is go via router 1, one packet is go via router 2, one packet is go via router 3, right? Let me clear ARP, clear ARP and ping 8.8.8.8. So ARP, so one packet is going via router 1. Let me clear ARP again, clear ARP and ping 8.8.8.8. So ARP, so MAC address is MAC address of forwarder 1. Now let me clear ARP again, clear ARP and let me ping 8.8.8. So ARP, so MAC address of forwarder 2, clear ARP and ping 8.8.8. So ARP, MAC address of PC1, sorry router 1, clear ARP, ping 8.8.8.8. So ARP, MAC address of PC1, sorry router 1, then again clear ARP, and let me ping 8.8.8. So ARP, so this is MAC address of forwarder 2, clear ARP, so ARP, MAC address of forwarder 3, clear ARP. You can check by yourself as well, right? You should configure GLLB in network, then only you will understand everything. So ARP, so now see MAC address of forwarder 1, clear ARP, देख लो लोड बैलेंसिंग हो कैसे रहा है, राइट? सो ARP, MAC address of PC router 1, and now it will send to router 2. Clear ARP ping 8.8.8.8. So ARP MAC address of forwarder 2 clear ARP and ping 8.8.8. So ARP MAC address of PC1. Again it will send MAC address of PC1, then it will send MAC address of router 2, then it will send MAC address of router 3, then again it will send MAC address of router 1, then router 2, then again router 1, router 2, then router 3, then again router 1, router 2, then router 2, then again router 2, then again router 1 and router 1, then router 2, and then router 3. Okay, so this is load balancing in GLBP, guys. Video length is increasing, so I am not going to discuss anything else in this video, right? But if you have any doubt, please let me know in comment. Definitely I will make one more video on GLBP protocol. Okay, but if you haven't any doubt, if you like this video, please hit on like button. If you haven't subscribed my channel, please subscribe this channel. We will meet soon in next video. Till then, bye bye guys, stay safe.